Here's an example in which we are dividing two complex numbers in polar form and giving the answer in polar form. So how do you do that? I want to divide Z1 over Z2 right here. So Z1 divided by Z2. How do we do it? Well, if you look on the notes that I provided at the top of module, here they are. The top, well, here I can show you here. You go to the notes at the top of module 5, the chapter 10.345 right here, notes, and you go way on down to number 8 and 9 actually, dividing complex numbers in polar form. There it is. I've got it over here for us. So here it is right here, dividing complex numbers in polar form. What do? You divide the numbers in the front and you subtract the angles, theta 1 minus theta 2. So if you have two complex numbers, you just divide the r's in the front, subtract the angles. Okay, that's pretty easy. Let's go up and do that. So I'm gonna divide the numbers in the front. So that would be the 10 and the 11. So let's divide the 10 and the 11. And I'll write it as a fraction first up, but then they want us to make it a decimal in a minute. And then cosine, and then we'll put a bracket here, cosine. And what are we supposed to do? We're supposed to subtract the angles. Now, it says theta 1 minus theta 2. And the one on the top, you know, is theta 1. So this one right here is theta 1, and this one here is theta 2. You know that the order of subtracting matters, right? 10 minus 2 is 8, and if you reverse it, it's negative 8. That's not the same. So order matters when you subtract two things. So if they give us theta 1 minus theta 2, we must follow the formula order. They say in the formula, right? If you look back down at the formula in the notes I gave to you, right here, you'll see that it says theta 1 minus theta 2, where theta 1 is the one that came from the first one, the one on top, and theta 2 is the one that came from Z2, which is the one on the bottom, must be second in the subtraction. Okay, so we got to keep that order. We can't just do whatever feels good or seems right to us. We got to follow that order. So because it's going to be counterintuitive here. You're going to go, wait a minute, you got to take 50, take away 95? Yeah. You got to put it in, but that seems backwards. That's the order we've got to follow. You got to start with the one on the top, even if that means a negative angle. Plus I sine, same thing here, 50 degrees minus 95 degrees. Okay, so then divide this on your calculator. I'm going to do it too. I'm getting 0.9, I don't know how many, oh, two places. Okay, 0.91. And then cosine, and this is negative 45 degrees, right? Plus I sine of negative 45. But, think, okay, good, we got it, we're done. Right here, make sure your angle answer is between 0 and 360. So make sure your angle is between 0 and 360, meaning it's got to be positive. We can't have that negative 45 degree angle. What are we going to do? That's what it came out to be, and we said that we had to follow the order, and so we had to put the one on the top first, and that happened to be the smaller one. We got a negative. Well, then you just got to add 360. Remember, you can always add 360 or subtract 360 from any angle, and it'll be the same in the end, right? Because if you turn all the way around, you're still facing the same direction in the end. So 360 minus 345, that'd be 315 degrees, right? Yeah. So that's the same angle. It's the same exact spot. 315. So there is the answer on that one. So when you divide two complex numbers in polar form, you divide the numbers in the front, subtract the angles, but you've got to do the one on top first, followed by the one on the bottom. And if that comes out negative, just add 360 to make it a positive angle that's really the same, just being said positive instead of negative. So notice when we divide two complex numbers, we divide the numbers in the front and subtract the angles. And then the formula says down here, when you multiply two complex numbers, you multiply the numbers in front, add the angles. Isn't that nice? This is de Moivre's theorem that he came up with, a French mathematician a long time ago. But when you multiply the numbers in front, add the angles. For dividing, you divide the numbers in front, subtract the angles. So that's what we do, and there's the answer we get.